And we are now at the top of the hour, so I would like to kick us off. Welcome, everyone, to the Data for Everyone class through the NNLM. My name is Sarah Gonzalez, and I'm a data librarian with Northwestern University's Galter Health Sciences Library and Learning Center, which is based out of Chicago, Illinois. I'm also a part of the National Evaluation Center, or NEC, with the NNLM, and we are representing also Region 6 from NNLM. And now I'd like to pass to my co-presenter to introduce himself.
Hi everyone, my name is Javier Martinez and I am the program specialist at the National Center for Data Services, which is part of NNLM. We are based at the NYU Health Sciences Library and I live in New York City. So pass it back to Sarah.
So as we kick off today, I'll do a quick introduction about NNLM. After that point, I will turn cameras off and then we'll really dig into what we'd like to share today on Data for Everyone. So now to kick off the things we would like to discuss today, we would like to ask, what do you think of when you hear the word data? And can you please take a few moments to put your associations with the word data into the chat? Okay, I've seen some great responses. Numbers, stats, research. Star Trek first. Great suggestions. Oh my gosh, so many. They're going very fast. Words, analytics, security, technology. Wonderful. Numbers, stats, analytics. Text, numbers, images, video, spreadsheets. Okay, so as we can see, and I think as a lot of us encounter in day-to-day work and life, there are so many things that fall under the umbrella of data. Lots of things we can think of that way and lots of things that we can process that way. So I think that we will be touching on a lot of these ideas as we continue our talk today. So thanks so much for contributing. And now let's talk about our specific learning objectives for the day. Our goals today are to define common data terms related to health data, to prepare a spreadsheet for creating a simple data visualization, and to identify further learning opportunities for working with data. So those are our goals. Please also, as we're going along, put any questions in the chat, and we will do our best to answer those either as we're going along, but definitely leaving a bit of time at the end for questions. So first, let's talk about some common data terms. And to set the stage for that, we would like to acknowledge that data is all around us. Every day, and in many ways, whether we're aware of it or not, we are generating data or working with data in some way. Maybe we're looking at the numbers in our health apps, noting how many hours we slept or steps we walked. Maybe we're looking over the metadata of something we want to watch on a streaming platform, noting the cast list, description, ratings, etc. Similarly, we could be looking over the descriptors of something that we would like to purchase on a shopping site, noting the cost, the description, whether the item is available in a variety of colors, sizes, etc. Or maybe we're wrangling a big event in our lives, like a wedding, and keeping track of guest names and addresses, food and flower orders, gift registry items, and much more. In each of these scenarios, we are collecting, evaluating, and making decisions for our lives based on data. So now let's move on to some key data definitions. It can be helpful to start with basic terminology to differentiate the data itself from some of its associated concepts and terms. Scientific data, according to the National Institutes of Health Data Management and Sharing Plan definition, is the recorded factual material that's commonly accepted in the scientific community as of sufficient quality to validate and replicate research findings, regardless of whether the data are used to support scholarly publications. And data is something that people tend to work with in stages. First, as a first stage usually, it must be collected and recorded. So data input can be defined as a way to capture or record raw data. Examples include health indicators, either entered into or maybe automatically recorded by a health app, or downloading a list of last year's Amazon purchases, another way of inputting data. A usual next stage of working with data is data processing. And processing involves converting the recorded data into a more meaningful form. Examples include tweezing out important information from a downloaded list of purchases or invoices and placing those pieces of information into a spreadsheet. So the things I might like to pick out and analyze could include product names, prices, dates of purchases, and whether the item was a gift or a personal purchase. So here's an example of what a spreadsheet containing that tweezed out shopping data from invoices might look like. Based on the particular budgeting questions that the shopper would like to answer, they can construct a spreadsheet with just a few columns and noting things like the product name, how many of each product was purchased, the date of purchase, the unit price, the total price, and whether the purchase was intended as a gift or as a personal item. By examining these column names and brainstorming a bit, we might already see some potential questions that this data could answer. Questions such as, how much money did the shopper spend on gifts in a given month? These ideas can lead us to our next group of definitions. Data analysis is the process of extracting meaningful information from data. It can involve simple sorting and counting, or it could involve more complex calculations. Some examples are included on the slide and include things like determining from the shopping data whether more money is spent in one particular month versus another, or determining how often repeat purchases of items happen to see if a good discount could be achieved by using a subscribe and save type of feature. Metadata is information that describes, explains, and otherwise contextualizes data. The column headers in the shopping data spreadsheet are an example of metadata because they describe what is being recorded, such as product names or prices. A variable is any type of symbol that represents information. In addition to being a type of metadata, the column headers in a shopping data spreadsheet are variables because they symbolize the shopping data that's recorded in each category. Variables can be found in both quantitative and qualitative types of data. A database is an organized collection of data stored electronically. The shopping data spreadsheet is an example of a very simple database. Databases can also be much more complex, storing multiple tables being spreadsheet-like listings of information, and storing hundreds and hundreds of variables. So next, let's move on now to the how-tos of setting up a spreadsheet to record a lot of this information. So commonly in studies, data is organized and wrangled in the spreadsheet format. It's helpful to understand basic terminology that's commonly used in spreadsheet-like settings. So a spreadsheet is set up according to a grid consisting of rectangles. Each individual rectangle is a cell, and each cell can contain some type of data, which is referred to as a value. Common formats for values are numeric, text, and date. Columns, as another key part of a spreadsheet, are the elements that run up and down on the spreadsheet. They're generally formatted to contain the variable as their column header or column name. The variable denotes the name of the data value category that will be collected. And these variables should be formatted to contain only one type of value. So therefore, all the values running down each column of a spreadsheet should have the same format. For example, they should all be date in one column, or all be numeric, or all text. And each cell should only contain a single value. The rows, as the last element of the spreadsheet, they run from left to right across the spreadsheet. And in this spreadsheet setting, rows are generally formatted to contain the instances of observation, which means the thing or the event about which you're recording information. Each instance of observation can consist of recording the values for many different variables. And while setting up columns in a spreadsheet, it's best to set up the data type or data format that each column is meant to collect as soon as possible. And this is done by selecting your column and right-clicking on it and choosing Format Cells from the menu. The most common format types are text, which is useful for data like product names, personal names, basically anything that must be recorded in words. Numeric, another common format. This is useful for simple numeric counts of things. So that could be prices, ages, basically any data that's recorded in a number form. And finally, dates are the most common type of format in addition to the other two. So you can record dates this way and sometimes both date and time. When you open the options in your spreadsheet program's date menu, there are quite a lot to choose from, many slightly differing date type of formats. So be sure to look those over very carefully and choose the date format that will work the best for your project. Here is a visual example of the data terms that we have just discussed. Each column in the spreadsheet has a column header, which is also its variable name. Columns run down the spreadsheet, while rows, or instances of observation, run across. Unique data values are recorded in each of the individual cells. And the columns are formatted specifically to their data, such as the date data being recorded in the month, day, year format. That's a particular date format. And also prices being recorded in the accounting format with 2 decimal places. So those are all very distinct variable value choices. Likewise, variables that must be recorded in full written words were formatted in the text format. So let's pause now just for a minute for a knowledge check. We've already learned quite a lot about the basics of data as we've just spoken today, and also some of its associated terms. So as a check, please type in the chat the letter for your response to the following question. Which of the following are true of data variables? A, variables are the symbols that represent some kind of information. B, variable names are typically recorded as the column headers of spreadsheets. C, variables can be found in both quantitative and qualitative data. Or D, all the above. Thanks to everyone providing answers in chat. Great, excellent, thank you. So we've got a lot of responses, and yes, the answer is D. It is true. Variables are all of the above. Okay. Thanks so much for participating in the knowledge check. And now I'm going to pass it over to Javier. Oh, I think you're muted.
I'm sorry, just having a little bit of a click here. And I'm wondering if everyone can see that.
Yes, we can.
Perfect. Thank you so much. So what we have here, we would like to continue by showing you a little bit of an example of how everyday data can be used to answer questions or create or present solutions. So as you can see here, this is an example of everyday data where a Reddit user recorded data about an activity that they do, likely using something like a fitness tracking app, as they attempted to bike 1,000 miles in 1 year. So you can see that this presents the data that they gathered across the 365 days. The graph on top is a line chart, and it shows the distance the person biked, and it accumulates as the year progresses. The bottom left is a bar chart. That's a different type of bar, showing their average speed. And then the bottom right is a pie chart showing the type of ride as a percentage of total rides taken. This example illustrates how data is found in everyday activities and also how one data set can answer many different questions. One data set, like this one, including columns for dates, distance biked, speed, and write type can produce several answers, but also different types of graphs that can help you illustrate your point in more compelling, or more or less compelling ways. So as we mentioned before, people work with data in stages, and we want to show you how easily that can be done. So as is usual with data, we want to answer a question. And so our question is going to be, what type of pets does this group have? So if you could just let us know in the chat. So what kind of pets do you have? Do you have dogs? Do you have cats? Others? Okay, I'm seeing lots of dogs and cats. I also have a dog who I love. Okay, so great. So what we want to do is we want to answer this question, right? And we just decided for the sake of this presentation to limit those options to the ones you see: dogs, cats, both cats and dogs, other, or none, which some people have. Great, I see a Python in here. That's really exciting. So what we want to do is we limited these options because we considered that these were the most common options that people were going to choose, but you can, in theory, gather as much or as little data as you wish. So now that we have collected our data, I would like to record that in a spreadsheet. So I have a blank spreadsheet here. In this case, it is very easy to name our columns. We are going to just name one of our columns. I'm going to name one of my columns pet type. And I'm going to name my other column N for number of responses. Now, I'm going to, under my pet type, I'm going to have the options that I provided for for our question, right? So it's going to be dogs, cats, both, other, and none. Okay. I personally like to bold my header rows because I think that that helps me differentiate between my data and my metadata. And then also, I'm going to put in numbers here. Now, I wasn't able to keep track because there are a lot of people here, but I'm going to put in some numbers here. We're going to say 15, 18, 20, and okay. So now that we have our values, we have values in 2 rows, and we have a row with headers for metadata. What I want to do is I want to make sure that I'm going to make sure that my spreadsheet runs smoothly. I'm going to choose my values, and I'm going to set up my type of data, to number, right? And I'm going to set it here to number. That will ensure that Google Sheets in this case can read these cells as numbers. Note that when I selected only my values and not my metadata. My metadata is it's usually formatted as text. Finally, what we can do is we can present this information in a more compelling way by creating a graph or a chart. So in order to do this, I'm going to select all of my information, and I'm going to go into the Insert menu and click Chart. And as you can see, now I have a pie chart showing me showing me a summary of the information that I have collected. So as you can see in this example that I created, the biggest portion of this pie chart is both. I can also change the chart type if I wanted, for example, a bar chart. And there are many other options to change things like the color and the other ways that the information is presented. Okay. Now, we also are have this planned in case you want to follow along. I'm going to do a second demonstration, collecting that smaller subset of data, a smaller group of data. So now we're going to go through the steps once more. So we're going to start with collecting our data using a poll. So for example, you can say, we are going to ask people if, we're going to ask the group if you prefer chocolate or vanilla. So take some time to put it in the chat, A or B. I'm seeing a lot of chocolate here. Which is wonderful. I also love chocolate ice cream or chocolate anything really. Great. So now I'm going to say, only because yes was not an option. Yes, I agree. I also like both. So we're going to do this once more. I've created another tab here, and I am going to, again, set up my table. I will have my flavors, right? And I'm going to call this N for number of respondents. I am going to have and now that I have a header, which I am again going to bold because I like for things to look a certain way, you don't have to do it, then we are going to select, we're going to enter our values. The first one being chocolate and the second one being vanilla. Then I'm going to put in my data. Again, I'm just not able to count exactly, but we're going to say that 100 people said chocolate and that 67 said vanilla. And you can feel free to follow along with this in your own spreadsheet program of your choice. It can be Sheets, Excel. There are many ways to work. There's a lot of software right now that you can use to work with data. I'm going to set up my cells format to be number because I'm going to I want to make sure that this works with numbers correctly. And then I'm going to select all of my information and click Insert Chart. And it's giving me a column chart, vanilla versus chocolate. I can change that to a pie chart, which is probably a more compelling way to present this specific information. And you can see the comparison here of what people have chosen. So up until now, does anybody have any questions? If you have any questions, you can put them in the chat and I'll be happy to answer them.
The last question that's there in chat, will we want to go into an extra formatting bit of advice, adjusting colors in the pie chart?
Yes, absolutely. We can totally do that. In this case, you can see it here on my chart. And I'm going to just double click this and you can see there's the setup where I'm going to put in all of I can specify the data. So in this case, it's my table. And then I can go into customize here in Google Sheets. And I have my pie slices. I can select my chocolate slice and change the color. I saw a very nice suggestion to change it to brown. So we are going to change that. This is interesting. I'm going to choose whatever looks closest to brown. And then I'm going to grab my vanilla slice and I can just click on the slices and change the color to something that looks like vanilla. There you go. And that way you can see it in the colors in a different color. I can also change the info. This is showing me the also percentages, which is a very nice way of doing it. So vanilla was 40.1% of the answers, while chocolate was 59.9%. So it's very easy to work with data and to present the data that you have collected in a compelling way with a very easy spreadsheet.
Thanks, Javier.
Yes, of course.
I'm curious to know, maybe please provide an answer in chat. Did anyone try out this exercise or the one before and run into trouble or have an unexpected result?
That's a great question. Okay, people are saying it went fine. If anyone ran into trouble, you can let us know in the chat and maybe we can answer any questions you may have. It seems like people want ice cream. That also is completely valid. Great. So if there are no other questions, what we want to do now is we want to talk to you about some further learning opportunities that you can find here at NNLM. So not just NLM, but further learning opportunities about data and working with data. So these are ideas of where you can go to get started, suggestions for NNLM classes. We are going to list all of those classes and we're going to list these classes, and then these slides contain links for the links for all of these classes as well. So the first thing we want to talk about is the NNLM data pathways. I'm going to copy the link to that in the chat right now. There are a number of classes from the NNLM on data, from data services and data science to data management plans and open science. We created a guide on the NNLM website, which is this guide, the NNLM Data Pathways, to help navigate these offerings. There are paths through generalist for those looking for a broader understanding of data librarianship, as well as data management, data science, but also for those looking to specialize in those areas. We've broken down the classes in the next couple slides along experience level. So these are the most introductory classes that you can see right now. On-demand classes are available now or anytime. They are asynchronous. The recently revised data services on-demand classes are each 4 hours long and include research data management, research data sharing, supporting open science, tools and trends, and data ethics. There are also on-demand classes on health data standards and the common data elements, which are a list or repository of standardized data collection items. There are also recorded webinars, which you can view on demand on the NNLM YouTube channel. A few that we've highlighted here are making sense of numbers, on communicating numerical health information, health statistics on the web, which features several portals for finding and exploring health statistics, and the research data landscape. How do you start and where does your library fit in? Which focuses on bringing data services to your library and where to start with building a data services program. Here are examples of more specific or more in-depth classes to help advance your skills or working with specific tools. Under data management, there's creating data management plans with DMP tool and fundamentals of health sciences research data management. That's one of our multi-week scheduled Moodle classes. Under data science, there's a new class on open tools for data de-identification, which focuses on the NLM Scrubber, a tool to remove protected health information from electronic health records that also discusses the basics of AI and data privacy. We also have fundamentals of health data sciences, which dives into the Python coding language over 10 weeks. You can keep an eye out for that because it is currently ongoing, but it may be open again in the future. Data management and sharing, data management and data sharing, those are very popular topics, especially with the NIH data management and sharing policy that went into effect in January of 2023. There is a webinar recording that gives an overview of the NIH DMS policy, or the NNLM hosted an on-demand immersion workshop in the winter of 2023, which is now available on demand. It features recordings and activities to complete centered around the NIH DMSP's 6 elements framework. The Practitioner's Perspective series is also comprised of recordings on the NIH DMS policy from experts in preparation for the NIH DMS policy. And finally, Region 3 hosted a webinar on the NIH Data Management and Sharing Policy for non-data librarians. You can find that recording on the NNLM YouTube channel as well. Now, if you would like to dive a little bit deeper than what we did today, or you want to step out of the NNLM realm, these are some non-NNLM options and classes that you can find out there. A good place to start is the Carpentries, which is an international reaching, nonprofit, and community-led organization. It teaches foundational coding and data science skills. Library Carpentry focuses on building software and data skills within library and information-related communities. All of their lessons and their materials are freely available, they're open, and you can follow along with their lessons and examples. The Data Services Continuing Professional Education is a 10-week online intensive learning experience geared toward preparing early to mid-career librarians to provide needed data services. That's a program that runs in the fall and consists of live lessons, remote self-paced learning, and a capstone. And applications tend to open in the summer, which is coming up. A couple further resources. The Data Literacy Project offers free courses on data foundations and data-informed decision-making, but is more business-focused. Georgia State University Library Research Data Services created micro-credential badges for becoming data ready. And there are recordings of all their workshops. Their program includes bite-sized intros to data literacy and full workshops on programs such as R, Python, SAS, and Tableau. The last article there discusses becoming data literate and how learning about data can enhance your communication, critical thinking, and research skills. This slide contains links to glossaries and other resources for commonly used data terminology in the health sciences. Many of the definitions that we use today were derived from these sources. They are also available in a handout that we'll send to you. Finally, this slide contains some of the upcoming NNLM classes related to working with data that I actually have already mentioned that are coming up. You can see that some of them are happening really soon. So we have the NIH Data Management and Sharing Policy Overview is happening April 8th, and the day after we're having the Research Data Services Landscape webinar, so that you can also attend. And then in June we're going to have Greatest Crimes in Statistics. You can register for all of these classes through the NNLM website, and these slides also contain links to the registration pages.
I'm seeing a few things in chat. There was a question about the slides being available after today. And yes, as Justin answered, they will be accessible on the event page shortly.
And I want to point out that these are classes related to data, but also there are plenty of other offerings through NNLM that you can take advantage to that are not related necessarily to data management and sharing.
Oh, I see a really great question. Is there any class on how to prepare data to upload into data sharing repositories?
I don't think we have a current class on that. That's a good topic to consider. There's so many repositories available that it might be a little overwhelming to do anything specific on that topic, but we will definitely think about that. We're currently brainstorming ways to add additional classes, so if you have any suggestions, feel free to email us. It's ncds@nnlm.gov, and I'll put that in the chat as well.
Yeah, thank you, Justin. And I think it's a multifaceted question as well that really involves several different aspects. I think part of preparing data to deposit in a repository will involve a certain amount of cleaning of data um, and getting it prepared in the sense of having tidy data that can be uploaded to certain repositories that may be strict in that sense. They might need column headers, those variable names named in a certain way. They might need certain metadata standards applied. So to some extent, tidy data courses that can be found online can help with those aspects. And then some of the preparatory data management and sharing plan classes, like how to write the DMSP, how to be compliant with it, those can help to answer some of the questions about what's a good repository to choose that's the best fit for my data, and also how do I apply metadata standards, what are the relevant standards in my field, etc. So combining together some of the information from some of these different sources can go a long way towards helping to figure out how to get that data ready for sharing. Great. Thanks, everyone, for the great comments in chat. I'm trying to keep track of these as we're going along.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.